Okay, so if you're just joining us, what is this? Number 65? 65. We're dealing with the, what this thing is. So this 65, we're dealing with the forcing function. So back here, we don't care. When you get to t equals 0, what's going to happen? F of t equals t. So you're going up, minding your own business on this line. So f of t equals t all the way until you hit 1. When you hit 1, what's going to happen is this will turn on, which essentially makes this t minus t. And so that zeroes things out, and you're 0 from then on. So anyway, once you have that, the rest of this is easy. I'm sure you could do the rest of this. It's getting that would be the problem. So now that I've got that, the rest of this, let me just go ahead and set this up. We might as well do some of this. There. Make sure that that makes sense. Any questions, concerns, problems, fears, worries? No. Okay. If we're happy with that, then, yeah, the rest of this is pretty straightforward. So give me a sec. We will do the Laplace transform. Whoops. So this is going to be s times the Laplace transform of y minus the initial condition, which is 0, plus 2 times the Laplace transform of y is equal to the Laplace transform of t minus the Laplace transform of u. Okay, so that's going to be e to the negative s times the Laplace transform of t plus 1. So let me just remind you that if we want to do the Laplace transform of a Heaviside function times something else, that something else better be time shifted, and if it isn't, then when we do the Laplace transform, we have to shift. So that's where this came from. So yeah, if you look at the table, which I could give you the quiz is right here, it doesn't really matter. Here, on the bottom of the quiz, you'll find this. Yeah, so here is what we're using. That one is this, but it comes with, it's not on any of the lists, I don't think in the book, maybe it is, but its mate, if you will, is that if you have u of t minus a times f of t, then the Laplace transform, whoops, I'll put it at the bottom here. There it is. Okay, so this is kind of the sibling of that. So if you have that, then this is going to be e to the negative as times the Laplace transform of f of t plus a. So that just corrects for the fact that you don't have a t minus a inside the function here. So you have to shift. It has to shift somewhere, and so there's where it shifts. Anyway, getting back down to here, that means that, yeah, that's why that turns into this. So once you're happy with that, then the rest of this is pretty straightforward. It's going to be s plus 2, Laplace transform of y is equal to 1 over s squared minus e to the negative s times 1 over s squared plus 1 over s. Should be in parentheses. So Laplace transform of y is equal to 1 over s plus 2 times s squared minus e to the negative s, 1 over s plus 2 s squared plus 1 over s. Oh, I messed up. That's better. Okay, now there's some partial fractions that we have to do to get the rest of this. But I'm guessing that the major issue here was this, that forcing function. And that once we have that, you can get the rest of the way. It's just there's some pain involved now, pain and suffering. But we can get there if we need to. But I want to make sure that we answer other questions, if there are any, before we, because like I said, I'm pretty sure you can do partial fractions. It's just painful. And we want to all avoid pain, don't we? I want to. so I'm gonna not do this now. All right, so what other questions do you have on the homework? We can come back to this if we need to. Let's just see if there's any other issues we need to do. Looks okay? All right, do we need to do the pain, or do we want to do the quiz? Maybe the quiz involves pain. What is the quiz? That's not bad. It's not too bad. Yes, there is a quiz. How about if we try the quiz? Since it's the day before an exam, I don't collect the quiz. It's just here for practice. So that's one thing that may give you a little solace, that you're not going to, it's just practice. Like I said, we do this because I want you to have a chance to fail before you take the test. I'd rather you fail on a quiz than on a test. So why don't we do this? Give it a try here. Work with a friend if you want to, but you should probably try it on your own first, and then you can pass these back. There's a few extras. Here, you want some?
Thanks.
Thank you, Ross. Yep. Here you go. Pass it on back there. Is there enough there? Maybe? Find out. You only get one? Here, one? Anyone else want one? Is everyone here? No, Darren's not here. So who's got the spare? Anyone have an extra? Maybe Darren's the only one missing, so here, just in case he shows. Okay, let's move that paint off the page. Okay, so I'll work through this as quickly as I can. We'll do a race, see who gets done first, and then I'll show you my answers when I get done. ooh, there's no initial condition for the second one. You can make it, here, I'll put it up on the screen. Y of 0 equals 0. That works. There we go. There, for number 2. That'll make things easy for you, hopefully. I'm all done, but I've got the wrong answer for number 3. So I'll poke around, try to figure out where my mistake is. Meanwhile, in a couple minutes, maybe 3 minutes, because that'll be at 35 after, we could go over, you could find my mistake. So hopefully someone's got number 3. I'll see if I can figure out where I went wrong. Ooh. I found my mistake. All right, I found my mistake, and now I'm happy. So if you really want to know what my mistake was, watch the video, because it's on the video. Got this frozen, but well, let's go ahead and see how you did. It's 25 till, so this will give us a chance to take a look at the practice test if need be. So first things first, number 1, pretty straightforward, just the annoyance of having to deal with the 11ths, but I think that's all correct here. So here, let's do this one step at a time. Pretty straightforward. Differential equation. So I've got, there's my Laplace transform for y prime, 11 times y, there it is, and then the 3. Let's make sure all of that is good. Then I solved for L of y, which I kind of skipped a step, I guess. But basically move this to the other side, and then you'll factor out s minus 11. And that's what goes to the denominator here, so the 3 over s becomes 3 over s times s minus 11. This 4 ends up there. Yeah, what do you think, Travis?
It should be 41, negative 41 over 11.
What, you're complaining about my final answer?
Yeah, it should be 3 minus 44.
That's what I originally had, and then I went back and checked my work. So I might be wrong, we'll check. So we're coming to it. So yeah, not to worry. Yeah, but I originally did have that. And then when I checked my work, I was like, something's wrong. But we'll see. Maybe my check was wrong, and so maybe you're right. Because yeah, like I said, that's what I got the first time. So anyway, going over here, here's what I got. So let's double check this, because this is, so yeah, and this is dangerous for me to do partial fractions in my head, but just so you know where this is all coming from, it's this stuff here. Let me make sure this highlighter is going to show up. Hold on a minute. There we go. So this thing turned into this stuff right here. So let's just double check that, because that's really the source of the 41/11ths or the 47/11ths is what I got. So here, let's see, if we were to multiply through, so s minus 11 times this, you get negative 3/11ths times s minus 11, which is negative 3/11ths times s, plus 3/11ths times 11, because the double negative, and so that'll give you positive 3, which is what I wanted, I believe, positive 3. Yeah, and then the 3/11ths times s would cancel with that. So I believe that should be negative, that should be positive. You want to double check? Because that's where I was at. And then when you add this to the 4, I got 47. Is that, I mean, am I wrong about that?
I combined all three of those, on the other side.
Over here, whoops.
Yeah, I did.
I'm in low power mode, so it's, right here you did this.
Yeah, I did.
So it's 4s plus 3.
Yeah.
Yeah, I didn't bother with that because I figured the 4 over s minus 11, it's already clean. You know, so yeah, in this case, yeah. So, but here we can double check one other way, and that is that if we get down to the end here, so we've got, so I combined the 3/11ths and the 4 to get 47/11ths, and then did the inverse Laplace transform. I got that, and then this became that. So you had 41/11ths plus. So we can easily check to see who's right by doing the derivative. So let me do the derivative up here in red. So y prime is 47 e to the 11t. Oh, I guess that's it. And then plug in what we have. So this becomes 47 e to the 11t should equal 11 times 47/11ths e to the 11t minus 3/11ths plus 3. So 47 e to the 11t is 47 e to the 11t, sorry, minus 3 plus 3. Check. So mine checks out. Yeah, so there must be something in your partial fractions. And like I said, no shame in that. I had that myself, my first answer, and then when I checked, I was like, that's not right. Same thing happened with my with problem 3, is I got done with it and I checked my answer with the original differential equation. I was like, oh, something's wrong. But I found my mistake with that one as well. So, well, one of the things I love about math that's not true of like biology is that you can actually check your work if you have time. Like with biology, is it the dorsal aorta or whatever? Like, I don't know. You can't check that, but you can check this. I love it. Okay, let's take a look at number 2. Unless other questions about 1? 1 is okay? 1 is good. Okay, let's take a look at 2. So for number 2, I was kind and had this, it all lined up here. So the Laplace transform was pretty straightforward. I skipped a step here because y of 0 is 0, and because I knew that you're going to factor out s plus 1 here. Always works out that way. Anyway, that should be your Laplace transform step. Yeah, basically this there. So you've got e to the t that you're doing Laplace. That's what this is. If you ignore this, you have e to the t. So s minus 1. Anyway, this one was pretty straightforward. In fact, it's going to surprise you how quickly I did this because, well, here, you'll see. So here's what I got when you divide both sides by s plus 1. And then, I don't know if you noticed, but this is on the table. You don't have to do partial fractions for this. So you look on the table, you'll see it. It's right there. hyperbolic sine. So, yeah, go check it out. Oh, I hope it's on our table. I never checked. Oh yeah, it's there, see? Hyperbolic sine. There, it's got that funny looking W, the omega. But yeah, so you could have done partial fractions, and if you did partial fractions, you would get whatever the hyperbolic sine is. That would be this, t minus 3 times e to the t minus 3 minus e to the negative t minus 3 all over 2. So if you did the partial fractions, you'd get something like that. Because the only reason I know that you'll get this is because this is hyperbolic sine. It's literally, that's what hyperbolic sine is. All right, so everyone happy with number 2? All right, onward, number 3. Like I said, if you really want to see where I made my mistake, you can watch the video. But here's what it looks like. So I've skipped a couple of steps here. So I did 2 things at once. I did the Laplace transforms, and I did a bunch of algebra. So the algebra I did was I factored out the Laplace transform of y, pretty straightforward. I also moved anything that involved, that didn't have Laplace of y, I put it on this side, and that included, there was a minus s over here, there was also a minus 1 and a plus 5, and I just combined those and shoved them over here. So double check that. And then of course the 6 over s, that's pretty straightforward. Okay, so next we do a little bit of algebra, and in this case I did combine, even though this 6 over s was, well actually no, the 6 over s, yeah, there's nothing here that I can just go ahead and do the inverse Laplace of. So I thought, let's combine it all into a single fraction and then do the partial fractions. So that's why I did that. Basically multiplying each of these by s so that I could write that as a common denominator over s before doing the division, and I factored. I know I'm skipping steps left and right. Sorry, it's in my nature. Well, I'm just trying to do it as quickly as possible because I know you have questions on the sample test. And also I want to show you the actual test so that you know what to expect. Okay, so here's what I got. So I know, it's like, here's the, after, what did I do here? Oh, I know, I didn't even show my work. So this is a over s, b over s minus 3, and c over s minus 2. And then I just multiplied by the common denominator and got this. And then, of course, I just picked a few values that were, you know, the obvious ones, s equals 0, 2, and 3, to zero out everything but one of the variables. And here's where I had made my mistake earlier. I had messed up some calculations here. But now this is super clean. I mean, you got A, B, and C is 1, negative 1, and 1. And then there's what you end up with. So I know I didn't show, here I could show the Laplace transform here. It would be this, the Laplace transform of y is equal to a over s plus b over s minus 3 plus c over s minus 2. And because it's negative, that's why that is negative. So. And then I just took that, used my table there. Yeah, what do you think, Peyton?
Could you just do the first step of like y double prime minus 5y? Like how you got it.
Oh, how I got all this mess. Yeah. So this is going to be s squared Laplace transform of y minus 1 times s minus 1. Whoops. Minus 5 times s times the Laplace transform of y. Okay, so here, just a sec. All of this thing here turned into all of this. And then this thing here is going to turn into the next bunch of stuff. This is minus 1 plus 6 times the Laplace transform of y is equal to 6 over s. So this stuff here, that's where y prime ended up. And then so then there's a whole bunch of algebra I did. So the algebra is this. So you have s squared times L of y minus 5s times L of y plus 6 times L of y. That's where all of this stuff came from. Then that S over there, that is this S, when you add it to both sides. And then the 4 that you can't see, there it is. That 4, what that is this is negative 5 times negative 1, which is positive 5, minus 1, positive 4, and then move it over and it becomes negative 4. So that's where everything came from. Yeah, I just trying to crank it out as quick. This is the way I make my, when I'm doing like the key for the exam, I just crank it out as quickly as possible. And then if I do make a mistake, I just figure I'll start marking them and they're like, oh, everyone's getting this one wrong. Maybe I should check that. So, yeah, if you ever get like marked off and then, okay, that's probably what happened. So, what else do we need to look at with this quiz? So you can do this. This isn't bad. It just takes forever. So hopefully the exam won't be terribly long. Let's take a look at the practice test. Now, I did notice online, let me just show you what I got here. Let me back up one notch. Boom. Hold on a minute. Pull this over. There it is. So I just copied from last year I copied the exams, and this little note was there, and I realized today that note doesn't apply to this year because our list of, our video list didn't have that junk at the bottom. So if you really want to see me muttering while I make answer key for the sample test problems, you can find the videos at the bottom of this. So I just copied the link there. So let me just show you really quick is what that looks like is this right here. Pull. Oh, no, that's not what it's going to look like to you. Just a minute. Let me just go over here and click. Just so you can see, it's at the bottom. These are from spring 2021, so apparently that's when I made up this practice test. Oh, yeah, there it is. Is that it? Yeah, test 3 videos. So I've got every single problem. So if you're like, I don't know how to do number 7, you can go here and find number 7, and then I'll be doing it. So there it is. They're all there, all the way up to 10. So anyway, there it is. Let me go back to, oh, yeah, I got to back up here. There it is. So here's the practice exam, and then it has the answers that I hope are correct, as always. The standard disclaimers apply. I guess that oh, here we go. So there it is. So you may or may not have had a chance to look at this. If not, that's fine. You have plenty of time before Wednesday. So Wednesday is the exam. Let me just briefly go through the actual exam, tell you what's on it. It's basically similar to this. In fact, I took this as a template and then modified things, of course. So at the front end, I have several initial value problems just like this, where I say don't use Laplace transforms. And the reason is I want to see that you remember how to use separation of variables. That's this first one. This is an exact equation. Can you do it? I bet you can. Down here, you have a linear differential equation. That one's been a problem for a lot of you, so make sure you can do your linear differential equation. This one is a second order thing, so hopefully you won't have any trouble with that. Why is this not moving? Hold on a minute. Where's the mouse? Oh, come on. There it is. It's on the wrong screen. There we go. Okay, so moving on. Yeah, so I'm looking at what am I looking at? That is the practice test. Where is the actual test? Oh, here's the actual test. Actual test. Same thing. So problem 1, basically the same, only I feel like the linear differential equation is a lot easier on the actual test than it is here. So that one, what is that, t cubed plus t? I don't even know what that is. Okay, next one. We have, oh, interesting. So I've got some second order differential equations. So I might change that. Yeah, I don't do this. That thing, not on your exam. I mean, basically it is, but it isn't. Not like that. We'll get to it, don't worry. Okay, so not on your exam. This is, so that's what I mean by it is, but it isn't. Is I give you a spring mass system with some some information, and I want you to write the differential equation, find the general solution, is it overdamped, underdamped, critically damped, that whole thing. So anyway, I'm just, like I said, I'm just going to tell you what's on the actual test here, and compare and contrast. So let's see, going on. Oh, wow, there's quite a few of those. So if you need extra practice, there's plenty of practice there. Okay, so there's some of this business. Second order differential equations, this is kind of, you've done this already. It should be easy for you. Technically, you could do this using Laplace transforms. It doesn't say you can't, but I'll tell you right now, do it the old, with the characteristic equation thing. It's going to be way easier like this. Yeah, it's just going to be easier. Just go ahead and do it. It'll be pretty simple. Oh, also, there is no initial value. So you can't use, you could. You could just say that the initial condition is y of 0 is equal to c1 and y prime of 0 is equal to c2 or something like that. Okay, so yeah, I'm comparing and contrasting here. Same thing, same thing. Okay, still same. Okay, Laplace transform. Did I delete that problem? Just a minute, I may have. No, I didn't. Sad. Yeah, so integral definition of Laplace transform to compute this. I know, you got to remember that integral. You remember the integral? We can go over this in a minute if you need to. Or you can watch the video of me muttering. It's always fun. Okay. I can say for sure that this is a little bit bigger, longer. Like it's not A through D, it's A through F for both of these. And the reason being that you'll notice on here that there aren't any Heaviside functions up here or down here. So in the actual test, it's similar, only a little expanded. So like I said, I deleted a few things, I've expanded a few things. So let me see what else we have here. So basically, can you do the Laplace transform of, say, a Heaviside function times e to the t or something like that? You can make your own up. But if you've been paying attention the past week, you're going to be fine. Let's see, onward. Yeah, find, okay, so there's some Laplace transform differential equations, and you'll notice that each one of these is pretty straightforward. Like I've got first order differential equations, which are super easy with Laplace transforms. Same thing here. First order, this is first order, this one second order, but on the test itself, it's similar. Let me look, just a minute. Yeah, I don't want you coming to me on Wednesday and yelling, I thought it was going to be easy. Let's see, yes, first order, and second order. Yeah, same basic pattern, just with different functions and different variables. Okay, and I moved the spring stuff to the very end. So, yeah, so that's it. Yeah, that's it. So it is similar. The main difference is, just so you know, so you don't go bonkers, is number 2 I deleted so that I can make room for a few more under this one here. So that you'd have a couple more here and a couple more here. So, like I said, I deleted number 2 and I added a couple to here and here. And one other thing, I don't think you have as many of these spring mass system things. Let's see, how many do you have here? 1, 2, 3. Yeah, 3. I don't think I have 3 on the actual test. Let me look. 1, 2. I only have 2. So, if you have other questions, you want me to tell you what's on the test? I can show you one of the problems if you want. Pick one. You don't believe me, do you? All right, I don't have to. It's fine. Wait, which one? What? Okay. Well, if you don't have one that you want to see, that's fine. No, they're like, how is this even possible, you're saying? Oh, I'll pick one. Yeah, since you don't know what you want to see, I'll just show you the very last one. Is that all right? Sure, sure. Let's do the last one. Here we go. This is the actual test here. Just so you can see, it is exactly the same as one of these. So here's number 3. So you see 3 here. You've got a mass of 1 kilogram, spring constant, and damping coefficient. So on the actual test, where is it? Come on, if I can make it bigger. Trying. Oh, that's really helpful, isn't it? Well, it's pretty helpful. So you have spring constant, 1 kilogram. K is 6, and the damping coefficient is 2. So it's a very similar feel. In fact, I think with both of these, let's see, b squared minus 4ac. Squared minus 4ac. This one, 36 minus, this one you end up with complex roots, and same thing with this one. They both have complex roots. Ooh, that one has it's driven by a force, so that's more like, which one is that more like? Just a minute. No, that one doesn't have a driving force. There it is. Ooh, good thing I just have cosine there, not this craziness here. So, very nice. So, any other issues, questions? I know, this is the only one I'll show you though. Sorry, you can watch the video if you didn't write it all down. Look at this, it's almost 3. So, do we need to have a Clash of Clans discussion? No, just kidding. All right, well, if you don't have any questions, here's what I'll do. I will stop the video, and then you can come up here to beg for mercy. Oh, if for some reason you're not going to be here on Wednesday, come remind me. You might have emailed me last week, but I don't remember that. So come remind me so I can make sure that we get your test taken care of whenever it needs to be. But hopefully everyone can be here. I'm going to stop the recording almost.